Hi, everybody, and thank you for joining us today for our Installation Intel webinar, Optimizing Spray Foam Without Sacrificing Performance. My name is Kim Melton, and I will be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. First and foremost is that many of us are working remotely. So if we run into any technical difficulties today that are disruptive to the presentation, we will pause the presentation for about 5 minutes. If we're not able to address those problems within that 5-minute time frame, we will cancel the presentation today and either send you a new invite for a future date, or we will record it and send you the live recording once that has been completed. So if you have any questions today during the presentation, you can submit them via the Q&A feature. You should see that to the right side of your screen. It should be a little dialog box. If you don't see the dialog box, and on the bottom right side, I apologize, these pictures are out of date, but they're on the bottom right side of your screen. You'll see 3 icons. One says participants, one says chat, and one has an ellipsis on it. If you click on that little ellipsis, there will be a Q&A in there, and you can actually open the dialog box that way to submit questions. Now, a quick note before we do get started, this webinar is for educational purposes only and shouldn't be used as a substitute for professional engineering design, consultation, or documentation that's required by building codes, contracts, or applicable laws. So if you have any questions after the webinar today, you can refer to our specific application guidelines and instructions, and those are located in the product sections of our website. Also, we'll follow today's webinar with a survey, and this is your opportunity to provide us with feedback on how we've done. You can use it to ask any additional questions you may have about the topic, or you can even suggest new topics for future webinars that you'd like to hear. But this survey is part of how we deliver the JM experience to you. Now, the JM experience is, you can see that there in the bottom left corner of your screen, and that's people, passion, perform, and protect. And those are the 4 pillars of the JM culture. We offer webinars like this one to help educate the market and offer a tool and a resource for you in your business. But this isn't just a one-way street. Your feedback is actually a key component to helping us evolve to better meet your needs. So if you have any comments or suggestions as to how we can better accomplish this, or even if you feel like we've missed the mark today, we'd encourage you to fill out that survey, and we'll use your feedback to improve our webinars and provide the information that has the most value to you in future webinars. Also, we're frequently asked whether or not we send out the webinars upon their completion. And while we don't send out the deck itself, we will post a recording of it online. And this is to ensure that you can watch the webinar within the full context of the presentation today. It also allows you to share it with your colleagues that you think may find it interesting. So with that, I'm going to turn it over to Chanel Charbonneau to introduce herself, and we will go ahead and get things started.
Thanks, Kim. So as Kim said, my name is Chanel Charbonneau. I am a product development engineer at JM, specifically for spray foam, and my contact information is below.
My name is Cassie Tottenhagen, and I am the spray foam product manager for JM, and my contact information is below. During this webinar, we're going to be talking about quite a few different topics. The first one is crucial characteristics of spray foam insulation and characteristics that apply to all spray foams, not Johns Manville products specifically. Next, we're going to go into what are high-lift spray foams and compare the installation times of high-lift spray foam to the Corbond product sprayed in multiple immediate passes. Next, we're going to talk about the optimized lift thicknesses for multiple immediate passes of JM Corbond III, the physical property comparison between the two of them, and understanding the impact of weather on spray foam installations. First, I'd like to start with the crucial spray foam characteristics. There are 2 key properties of spray foam that form the basis for physical and thermal performance. These properties will remain consistent amongst most spray polyurethane products and are not specific to the Corbond product line. These 2 properties are density and the closed cell content, and they also help differentiate between open cell and closed cell foams. Closed cell has a relatively higher density, around 2 pounds per cubic foot, and a higher closed cell content. Open cell, on the other hand, has a lower density of around 0.5 pound per cubic foot and a much lower closed cell content. In this presentation, we'll be focusing mostly on closed cell foams. First, I'm going to define density. In general terms, density is defined as the mass per unit area of a substance. But what does this mean in the context of spray foam? Pure polyurethane is used in many applications all around us, such as bowling balls and coatings. The density of pure polyurethane is close to 65 pounds per cubic foot, and it's an extremely dense substance. However, when spray polyurethane foam is produced, there's a blowing agent that is added and it creates a cell structure and gas bubbles in the foam. The gas inside the bubbles may be air or a blowing agent. Closed-cell foams are usually produced using a physical blowing agent, while open-cell foams are insulated by air. Closed-cell foam has a higher R value per inch than open-cell because of the blowing agent that resists heat flow throughout the product. In addition to R value, density will also impact other physical properties in the foam. The cell wall matrix is what gives the foam strength and structure, and it dictates whether the blowing agent will remain in those bubbles or whether it will diffuse out. So for our purposes, density is a measure of the ratio of polyurethane cell walls to the relatively massless blowing agent. A closed-cell foam with a higher density has more plastic or polyurethane cell walls in the matrix, which can improve some of the physical properties. Additionally, when the density is higher, there are not only more cell walls, but the cell walls themselves are thicker. The cell walls, being more plentiful and thicker, are less likely to stretch and break and are more likely to keep blowing agent from diffusing out of them. The main aspects of physical performance that are improved by density are the R value and dimensional stability, which we will discuss in detail during this webinar. However, with most physical properties in spray foam, there are many factors that influence each one. Another one of those factors is closed cell content. Closed cell content is defined as the proportion of discrete closed-off cells in a foam sample. This is the amount of fully formed gas bubbles without voids or pockets. In a sample with a high closed cell content, the cell walls are fully intact and gas cannot travel from one cell to another. According to AC 377, which is the industry-wide standard for spray foam, a 2-pound closed cell foam must be tested to have a closed cell content of 90% or more. This is readily achievable at lower pass thicknesses and densities around 2 pounds per cubic foot. But as lifts increase, cells can stretch and break. If you cut through a sample of closed-cell foam with a closed-cell content of less than 90%, you may see large visible air pockets, often called wormholes. These wormholes let valuable blowing agent escape and can cause the foam to lose insulating power. For reference, open-cell foam typically has less than 10% of closed cells. Additionally, fewer closed cells means that there's larger air gaps, which can exert inward pressure as the blowing agent diffuses out of the cells, leading the cells to collapse and negatively impact the dimensional stability. In the field, this can look like a foam sample shrinking and potentially detaching from the substrates and framing members. We'll talk more about this later. Finally, R value will be negatively impacted as blowing agent diffuses out of the cells. With the blowing agent no longer intact, providing heat flow resistance in the foam, lower R values could be expected with lower closed cell content. Now that we've covered some of the physical properties of spray foam, density, and closed cell content, what other characteristics are critical for spray foam insulation? Fire resistance, dimensional stability, thermal performance, structural stability, and substrate adhesion are all critical aspects of spray foam and ultimately dictate the long-term performance of a spray foam product. Most of these properties can be influenced by the combination of density and closed cell content. Beyond product choice, there are a few key points to be aware of when spray foam is installed in order to ensure optimal quality. These will apply to most spray foam products on the market and are not exclusive to the Corbond product line. When installing spray foam in the field, substrate integrity is critical. It is impossible to build a skyscraper on a faulty foundation, and the same applies to the substrate of spray foam. The substrate must be clean, dry, and sound. The first step of using spray foam is designing a building to ensure that the substrate is sound. Some examples are plywood, OSB, and concrete. Spray foam readily adheres to all of these. Some examples of non-sound substrates, which can lead to adhesion issues regardless of your product choice, are cardboard, foil wrap, and fiberglass bats. These substrates are to be avoided as they can be easily warped by the installation of the foam. After the proper substrate has been selected and prior to the installation of spray foam, the installer needs to check that the substrate is free of dirt and debris and contains less than 17% moisture content as measured by a moisture meter, as both can lead to adhesion issues. One watch-out that I'd like to discuss is stainless steel. Stainless steel passes the first test of being a sound substrate, and the spray foam may be applied to steel with great results. However, extra care must be taken to ensure it is properly primed. The image on the left shows a close-up of a foam sample sprayed onto oily steel. The cells on the left contacted the substrate and warped, which caused the foam to detach from the substrate. On the right side, you can see the interior of the foam where the cells are still intact. When we look at the cell structure, we can see on the left that the density and closed cell content are not consistent throughout the sample, and this will impact the physical performance of the foam. In this situation, it led to a failure in the substrate adhesion. So when spraying onto steel, please ensure that it has been cleaned and primed properly to avoid the risk of adhesion issues. The next factor that I want to address with choosing your spray foam product is the environmental conditions. And while we cannot control the environmental conditions themselves, we can control the installation techniques and product selection in order to overcome some of the negative impacts of extreme cold and hot conditions. Below 20 degrees Fahrenheit, spray foam contractors should use winter formulations, which are designed to perform better in lower temperatures. However, even with this special formulation, you can expect to see lower coverage in colder temperatures. When a low-quality foam is used, it may also cause adhesion issues, which in extreme cases can appear as the foam cracking off the substrate and framing members. On the other side, heat and humidity also have special considerations. In warmer temperatures, be sure to use a summer formulation. Heat can help with coverage, but it can also impact structural stability and lead to distortion if a low-quality foam is used. If you have any further questions on how environmental conditions impact spray foam and how to overcome them, please contact our Tech Connect team. The final aspect to ensure top quality of your installed spray foam is specifying inspections. As the chemical manufacturer of spray foam raw materials, we have Johns Manville has many quality controls that are put in place before our product leaves our facilities. Johns Manville's position is that the spray foam contractor is the manufacturer of the spray foam installation, and that JM provides the chemicals or the raw materials in order to be used. The installer should have a technical representative perform the necessary approvals for each job. Johns Manville provides free installation documentation and training in order to assist our customers on being the best manufacturers of spray foam, but the final installation is solely dependent on the contractor, as there are many factors on site that are in the sole control of the installer. It is important to note that JM has no legal agreement with the building owner. If you have any further questions on JM's recommended inspection and documentation techniques, or would like to get free spray foam installer training, please reach out to our Tech Connect team. Contact information is on our website at the end of this webinar. Next, I'm going to pass it off to Chanel to discuss what are high-lift spray foams.
Thank you, Cassie. So now that we know what the properties of spray foam are and some application considerations, what are high-lift spray foams? So high-lift closed-cell spray foams are becoming more and more popular in the industry. They are distinct from traditional foams in that they may be sprayed in one single pass from 4 inches up to over 6 inches, rather than in multiple passes with the waiting period in between to achieve the same total thickness. A high-lift foam might be chosen for several reasons. Even before COVID-19, compressed timelines and a shortage of skilled labor were prevalent in the construction industry. Now, with these challenges exacerbated, we are all looking for ways to get projects back on track and completed with the highest degree of quality. A high-lift foam might seem like a solution, but these types of products come with risks as well. Johns Manville has completed extensive testing on high-lift foams and identified discrepancies between the values you might find on a technical data sheet and lab-tested physical properties on high-lift foam sprayed to the manufacturer's recommended maximum pass thickness. In other words, the physical and thermal properties at a typical 2-inch pass are not always the same as those you get at high pass thicknesses, such as 5 to 6 inches, even if the manufacturer recommends such thicknesses. These degraded properties, often seen at higher lifts, may cause lowered foam density and closed cell content, especially in the core of the sample, leading to problems with structural integrity and elongated or broken cells. Finally, high-lift products are not permissible at all in Canada, demonstrating that the risks are known to the wider SPF industry. The next question is, are these risks worth it? Does high-lift foam actually save install time? Spray foam is created through the exothermic chemical reaction of an A and a B side. This reaction can result in temperatures of 350 degrees or more in some cases. Typically, the high temperatures generated by this reaction have necessitated a wait time between thinner passes to avoid excessive heat buildup, which can result in charring in the center of the foam, or in severe cases, ignition. In the photo on the right, closed cell spray foam was mistakenly sprayed in a single 16-inch pass, leading to charring. Though you won't see any manufacturers recommending 16-inch lifts anytime soon, it's a good reminder of the importance of keeping heat buildup in check. JM performed a temperature study on Corbond III sprayed in 4 immediate passes to 7 inches to determine whether there was a risk of charring. A thermocouple inserted to the core of the sample recorded temperature over a 5-hour window while the foam was allowed to cure. The maximum temperature observed was 300 degrees lower than its own self-ignition temperature and 150 degrees lower than the ignition temperature of wood, indicating that Corbond III will not self-ignite or, when in contact with wood, is not susceptible to causing a fire. After cure, the sample was cut into and no charring or deformation was observed. Therefore, Corbond III is not at an increased risk of fire when sprayed to 7 inches in 4 passes, and the 30-minute waiting period can be eliminated. This exotherm evaluation, along with extensive testing on physical and thermal properties, has led JM to recommend options of 1, 2, 3, or 4 passes sprayed without wait time, achieving an R value of up to R49. You can find this table on the technical datasheet for Corbond III located on jm.com. In addition to study on just Corbond III, a high-lift product was selected for comparison via several different metrics. Firstly, a time study was completed. The cavities on the left are a high-lift product applied in a single pass, and the rightmost cavities are Corbond III in 4 immediate passes. The average installation time was nearly the same for both products, indicating that the perception that high-lift foam saved time might not be backed up by data. But time is not the only important attribute to a quality install. The high-lift foam had inconsistent thicknesses along the length of the cavity, which may require an installer to return for touch-ups to get the required R value, adding time. It is also more challenging to install a single thick pass, requiring a skilled, experienced installer to get it right the first time without touch-ups. Especially with regards to spray foam, however, it's not all about time. Physical properties are crucial to ensuring long-term performance. Though single pass and multiple pass installation have been shown to take a similar amount of time, the physical properties they exhibit after cure may be vastly different. This is very clearly illustrated in these 2 photos. Though they are the same thickness, the multiple pass sample shows excellent dimensional stability and consistent density. The single pass sample on the right, however, is buckled in the center from its low core density and closed cell content. So let's explore these properties in more detail. JM looked at both foams under a scanning electron microscope to compare the macro scale characteristics to the micro scale. Corbond III has clearly defined uniform cells which are not deformed or broken. This matches up with what we saw in the full-scale image. In contrast, the cells of the high-lift product A have stretched and deformed, enough to break them completely in some places. This is what the buckling seen in the full-scale picture looks like on a cellular level. So buckling does not just make the cells look deformed and broken. It has a detrimental effect on real-world performance, including in the realms of dimensional stability, thermal performance, structural stability, and substrate adhesion. One important test required for a spray foam product to be accepted by building codes is the dimensional stability test, ASTM D2126. In this test method, a sample is subjected to extreme conditions for 7 days. The required condition for AC377 is 158 degrees Fahrenheit and 97% relative humidity, and the sample cannot distort by more than 15% volumetrically. Good samples change somewhere in the range of 1 to 3%, while less dimensionally stable samples have been observed to change by more than 40%. JM Corbond III in 4 passes to 7 inches was tested according to this method. As you can see in the photos, the sample exhibited minimal distortion and change in volume. Adhesion between passes was also cohesive throughout. We also wanted to see what Corbond III would look like tested this way when sprayed even beyond our recommended thickness to ensure we are leaving a margin of error. At 5 inches, the sample still exhibited the same excellent dimensional stability and lack of distortion. JM still recommends a maximum pass thickness of 4 inches, as ASTM D2126 does not cover all installation conditions. Now that we've seen how Corbond III performs, what can a high-lift product look like after hot and humid aging? The answer is not so great. The sample was sprayed according to the manufacturer's instructions, including spray parameters and pass thickness. Still, it resulted in significant distortion and had a volume change of over 30%, failing the acceptance criteria. In a side-by-side comparison, the difference is even more clear. Corbond III visibly outperformed the high-lift product at the most extreme ASTM D2126 dimensional stability test. Failing the acceptance criteria for dimensional stability can lead to real-world problems. A product with a high rate of shrinkage may pull away from the surrounding structural supports and substrate. If the foam has poor dimensional stability but good adhesion, it can pull on the framing members and potentially damage them. If it has both poor dimensional stability and adhesion, it may crack off or even detach completely from the framing, leading to gaps and negating the air and vapor sealing properties of closed-cell foam. This also creates opportunities for moisture penetration, which can jeopardize the long-term integrity of a building. In short, the poor physical properties that high-lift spray foam may exhibit can compromise the overall efficacy of the material. JM has identified some solutions, which I will hand off to Cassie to explain.
Thank you, Chanel. So Johns Manville has 3 separate recommendations for the use of high-lift foams. Our first recommendation is there are many solutions that JM recommends for the solution to high-lift foams. The first solution we have is to request actual test data from your spray foam manufacturer prior to specifying or installing a high-lift foam. Ask for data that was generated on samples that mimic the conditions you are specifying or installing to. Ensure that the data listed on the datasheet or other documents has not been extrapolated from thinner passes. Also, ensure that the material and all physical properties have been thoroughly tested and vetted for your specific application. Additionally, you can spray the high-lift foam in thinner passes. This will help control the density of the foam, and it will also help to ensure that the physical characteristics are maintained throughout the entire sample. If this technique is chosen, please consult with your spray foam manufacturer and their documentation because a 30-minute cooling time may be required to protect the foam and the substrate from charring or ignition. The other alternative that Johns Manville recommends is using JM Corbond III. The formulation has been optimized for multiple immediate passes without wait time in between that will not sacrifice safety, physical, or performance characteristics. JM's recommended pass thickness chart is located on this slide, but it can also be found on the Corbond III datasheet or at jm.com. Our maximum thickness for one pass would be 4 inches, and up to 4 passes with each individual pass as 1.75 inches, immediately sprayed after each other to achieve a total thickness of 7 inches and R49. Next, I'm going to pass it off to Kim so she can go through the additional resources that JM has for accessing this information.
Great, thank you so much, Cassie. So we did have one request, and I'm going to jump back in the deck really quickly to accommodate this request. The first one was for your contact information. We sped through those slides pretty quickly. So just a quick jump backwards. This is Chanel's contact information, and that's chanel.charbonneau@jm.com with a phone number of 303-877-4066. And again, Chanel is the specific spray foam product development engineer. I'll leave that up there for just a minute as that last name is a little French and might slow some of us down. All right, the next one is Cassie Tottenhagen. She is our spray foam product manager, and that's cassie.tottenhagen@jm.com. And her phone number is 303-978-3516. So we'll leave that there for just a moment so people can write this down. And again, if you have any questions, I'll talk through another resource that you can reach out to. And you can also submit any questions you have today via the Q&A or in the survey to follow up as well. So with that, I do want to talk about some additional resources that we have for people who are specifically interested in spray foam. And the first one here that I want to talk about is our spray foam installer training. So this is something that JM offers specifically to spray foam installers. And the reason being is that spray foam installation is critical to ensuring that you get the performance that you need out of the product. And so what we offer is a spray foam installation training course, and you can find access to that on our webpage. And so basically, if you go to the Johns Manville website and you go to the insulation tab and select building insulation, and then go to the spray foam installation page, on the right side of the page, you'll see this menu, and at the bottom of that menu is the spray foam certification. So if you click on that, you'll actually be able to get the information as to how to sign up for that training. In addition to that, I know we went through some of these slides pretty quickly with a lot of scientific information in them, so we will have a white paper that we're going to be sending out to everybody who attended and registered for the webinar today. This white paper discusses the exact same stuff that we discussed here in our presentation today, and it is called Exploring the Efficacy of High-Lift Spray Foam Installation. The purpose of the white paper was to really discuss and dive into whether or not high-lift spray foams can be used as a competitive product when you're comparing it to a product like JM Corbond III that can be installed in immediate successive passes. So again, if you're looking for additional information on the topics we've discussed here today, this white paper actually will be very helpful, and we'll send it directly to you with the recording of the webinar as well. Now, speaking of the recording of the webinar, that's going to be posted online on the source. If you go to the jm.com/the source, you'll find the building insulation resource library, and on there you have is where we'll have all of our webinars. We also have links to our latest blogs, information about our products, technical documentation, tools designed to help make installing and specifying these materials easier, and then online training as well. So this is a great resource for anybody who's looking for more information, more educational opportunities to help develop their internal skills. Additionally, we have the JM Smart Binder, and this is an app you can download to your Android or Apple iPhone. And basically, this gives you access to all of our technical documentation for all of our products right there on your cell phone. So it's a very easy way for you to get quick access to the most important information when it comes to specifying and installing our products. Now, another one I want to highlight here for anybody who needs additional help or support is our JM Tech Connect. And we say online, on call, on site. So we actually have a Tech Connect team specifically designated for our spray foam product, and you can reach them at 1-800-654-3103. And these people are designed to help you with specifications. They're designed to help you with installations, training, anytime you're having any technical problems. So this is a great resource for anybody who's looking for additional information. And then finally, we have a certificate of completion. Now, everybody who attended today will have a certificate of completion sent to their inbox, and that's going to be, I believe it'll be delivered by next Monday. And with that, you can use it to submit it for additional learning, continuing education credits, and so on and so forth. So quite a few additional resources there, but let's go ahead and dive into questions. Chanel and Cassie, are you guys ready to take some of the questions we've had submitted?
Yes, I am.
Yep, I'm ready as well.
Perfect. So, Cassie, this first question is for you, and this might be more geared towards California, but what impact will spray foam have on the new codes?
So I would actually answer this question the other way around, is what impact will the new codes have on spray foam? Codes are increasingly going towards fewer air changes per hour in order to have higher efficiency homes, and spray foam is a potential solution to meet those new codes. So if you have further questions on your specific design, please feel free to reach out to our specifier services, because I do think that spray foam will become more popular as those air changes per hour become less and less.
All right, thank you. The next question we have is, it's for you, Chanel, and that is, what about combustibility? Is there a non-combustible spray product, and what are the issues both from the outside NFPA 285 and the inside fire-rated separation?
So spray foam, either open cell or closed cell, both have to be separated from occupied spaces by a thermal barrier, or in some cases an ignition barrier, specifically in unvented attic applications. As far as a non-combustible spray foam product, polyurethane is a combustible material. So in terms of a non-combustible product, that would have to be, it wouldn't fall under the realm of spray polyurethane foam specifically.
All right, perfect. Thank you so much. The next question is for you, Cassie, and how does your product link with the installation standard in Canada?
We have a Corbond III product that is available in Canada, so I would encourage you to make sure that you're working closely with CCMC to make sure that you are a certified installer, but we do have products that are approved by CCMC for use in Canada.
All right, great, thank you. Cassie, I'll pose the next question to you, and then Chanel, you might want to chime in at the end, and that is, what has been your experience with architect builder acceptance of the HFO blowing agent in spray foam?
I would say that the acceptance by architect has been very strong. It is a regulation in some states in the United States, and it is going to be required in Canada as of January 1st, 2021. So I would say that the architects and specifiers do an excellent job making sure that they comply with all state and local regulations. So I think because of that, the acceptance has been high.
Chanel, is there anything you'd like to add?
No, I think Cassie captured it.
All right, perfect. So the next question is for you, Cassie, and that is, could I use, what about using a couple inches of closed cell spray foam and then topping off the cavity wall with open cell?
I would say to look at your specific design guides and look at what physical properties that you need to achieve. If you're hoping to get a vapor barrier, it's important to spray the closed cell foam to the appropriate thickness to ensure that a vapor barrier is present. I would also say that you need to consider the changeover of the equipment. Most closed cell and open cell systems are not compatible with each other. So if you have a very robust flushing system to ensure that either you're using a second rig that's only for open cell or that you have a good flush process between the two chemicals to ensure that there won't be contamination, that is something you could do. And if you would like to talk with us more about your specific application, please feel free to reach out.
Excellent. Chanel, is there anything you'd like to add to that one?
Nope, that all sounds good to me.
All right, perfect. Well, the next question is for you, Chanel, and that is a water-blown system not really advisable for spray foam because of its high tendency to collapse?
So this depends on whether we're talking about water-blown closed cell or water-blown open cell, which is all open cell actually. So if it's open cell, that wouldn't lead to any problems, of course. For closed cell, JM does not offer a water-blown closed cell product. The poor dimensional stability of these types of products is actually the reason why I don't think they're very popular. But that can be, I guess, negated with a different type of formulation.
So please be sure to reach out to your manufacturer if you have any questions about a specific water-blown closed cell system that you're using, because we cannot answer any questions since we don't have our own product.
Perfect, thank you. I'm going to pose this one to both of you. I'm not sure who would be most appropriate. So that is the International Building Code 2603.4 thermal barriers sprayed on insulation to be left exposed, i.e. fireproof paint, DC 315. Who would like to take that one?
I can take this one. There are a variety of different thermal barriers and ignition barriers on the market, so before you choose a thermal or ignition barrier, be sure to look at the evaluation service report provided by the manufacturer of the thermal barrier or the manufacturer of the spray foam to find out if your systems will be compatible with each other, because they do go through rigorous fire testing in order to ensure that the spray foam will perform well in the field.
Excellent. Thank you, Cassie. This next question is also for you, Cassie, and that is a moisture barrier needed when you're using closed cell spray foam?
So I'm going to answer the question in the way I think it was intended to be asked, so if not, please correct me. But a moisture barrier might not be required if you are using closed cell spray foam. Closed cell spray foam does become a vapor barrier at certain thicknesses, so if you're spraying it thick enough to be a vapor barrier, you will not need an additional vapor barrier in your system.
Excellent, thank you. Chanel, the next question is for you, and this person is interested in R values at lower temperatures like 40 degrees and lower. Most foams only list R values at 75 degrees Fahrenheit, which can be much higher than the average lowest temps.
Yeah, that's a great question. So in terms of the spray foam acceptance criteria, only R value at 75 degrees Fahrenheit is required. So any other testing at different temperatures is not required to be disclosed by manufacturers. I can say that just some internal testing has indicated that closed cell spray foam performs very well at low temperatures.
All right, excellent, thank you. The next follow-up question to that was, what is the temperature for summer formulation?
So this will depend on the product, but for Corbond III, our summer formulation, the substrate temperature needs to be between 45 and 120 degrees Fahrenheit.
Thank you, Chanel. Cassie, you started talking a little bit about coverage, and one of the questions we had is, what is lower coverage? So can you talk a little bit about what you meant by lower coverage and how that varies between each formulation?
Yes, so each formulation has what is known as coverage or yield in the industry, and essentially this is how much finished product is made out of one set of material. So when we talk about lower coverage in the winter formulations, typically across the industry, you'll see that winter formulas experience anywhere from a 1 to 300 board foot reduction in yield per set for the winter formulas.
All right, thank you. Chanel, the next question for you, and that is 17% a normal substrate moisture content that would be a realistic cutoff point for the closed cell line?
Yep, that's a realistic cutoff point. 17%. To achieve that in wood, you'd have to be in a very humid environment. It's certainly possible, and that's why we really advise that you check it. But 17% would be pretty high.
Great. The next question I have, Chanel, I'm going to pose this one to you, and that one is high-lift foam better for thermal resistance because it has a lack of skin between multiple passes?
Not necessarily. That's really related on whether you have that blowing agent diffusion out of the more open cells, especially in the core of the sample. So that really depends on the product. So I would just advise checking with your manufacturer to see whether they've completed that specific type of testing.
I would like to follow up and say that you kind of have two factors working with you when it comes to your physical performance. Yes, the knit lines, which is where any two passes of foam come together, is a densified version of that plastic, however, which can lower your R value. However, the open cell content and the lower density in the center of your sample can lower your R value and your physical properties by even more. The knit lines actually do help with not necessarily R value, but with dimensional stability. It is a stronger layer of plastic, which helps keep the full sample and the full foam intact in the wall cavity. So you do have to, it's not as easy as saying that one is better than the other. You have to look at how those knit lines interact and how the center of the higher lift foam interacts, because there's actually not enough plastic in there without those multiple passes in order to get the physical properties that you should expect.
Thanks, Cassie.
Great, thank you guys. So the next question that we have is, can a total thickness of over 7 inches be installed in multiple passes?
So yes, that's possible. In that case, you would just need to take that 30-minute wait time just to ensure that you're not leading to excessive heat buildup. So it's possible, but you do have to include that wait time.
All right. The next question is for you, Chanel, and that is, are closed cell spray foams better for fire resistance?
So closed cell and open cell both have different strengths and weaknesses. In terms of fire resistance, both have to be separated from occupied space by the thermal barrier. So it really leads to the same conclusion on that.
All right, thank you. Cassie, the next question is for you, and that is, do city inspectors fail the shrinking spray foam on projects, or who would that responsibility fall to?
So this question is designed to be inclusive. So the city inspectors will fail a shrinking system if they see it in the walls. However, what we noticed is the samples only failed after they were subjected to that dimensional stability test. And that is a very aggressive test that is designed to show accelerated aging of the foam. So it is definitely possible that the foam will look good for the period of time during the inspection until drywall gets placed over it or the foam is covered with something else. So it's likely that it is possible that these issues wouldn't be caught until a further inspection down the line. So while it is possible that it will fail readily in the cavity from the time it is sprayed to the time it is inspected, if that's the case, it will fail the inspection. However, it's possible that as it ages and distorts during the aging process, that it would not be caught by an inspector.
Yeah, and just to add on to that, sorry, as Cassie said earlier in the slides, it also falls to the spray foam contractor to do their own inspection and ensure that they don't see any of that cracking, even before a city inspector gets in the building.
Thank you, guys. So we actually just had a follow-up question come through that I'm going to ask right now, and that is, how do you fix a failed inspection?
There are a few ways that you can fix a failed inspection. Our first recommendation would be to ensure that you talk to our tech team because they are much more detailed and familiar with mediation techniques. It is possible, though, that the foam may need to be completely removed from the building and resprayed in order to correct the issue. There may be some intermediary steps that can be taken depending on the extent of the damage. So reach out to your tech team in order to help work through that. And if it can't be worked through, you would have to completely remove all of the foam and respray the foam.
All right, thank you, Cassie. Cassie, the next question is also for you, and that is, when you're changing from open cell to closed cell, can they be mixed in the lines until one is flushed out?
You would have to be spraying off target anytime the chemicals are mixed. They are not designed to be compatible with each other, so you will get really poor adhesion, really poor cell structure, really poor thermal performance. We have done no physical testing on mixtures of closed cell and open cell. So while you don't have to have a robust flush system, you would need to spray off target and not into a wall cavity until you complete your inspection test to know that you are spraying 100% the new formulation.
All right, thank you. The next question is for you, Chanel, and that is, I see that you're using R factor values to describe the insulation efficiency factors of the spray foam. What about the seamless and fully adhered nature of the product?
Yeah, so that's actually one of the biggest advantages of spray foam over other insulations is that, you know, when sprayed correctly and when you're not seeing the cracking between the foam and the substrate, it is a seamless and fully adhered, I guess, seal between the foam and the substrate. So that's what gives you your air and vapor seal. And it's really the biggest, or one of the biggest advantages of spray foam, in addition to the higher R value.
All right, thank you. The next question is for you again, Chanel, and that is, do you have any ICC reports available as a tech resource for open and closed cell spray foams?
So we have our evaluation service reports that are designed for the building code inspections. Those are available on jm.com.
I'd like to follow this up with ICC is just one of many companies that is able to issue evaluation service reports. So manufacturers have their choice of evaluation service report, but they're all based on ASTM standards and standardized tests that are completed by third-party labs. So we do have evaluation service reports. Some of them are with ICC and some of them are with other labs. That is similar to what you'll find amongst most spray foam manufacturers.
All right, thank you. So the next question we have is, how can an architect field check the thickness during a field visit?
Chanel?
Yeah, so there are different, the easiest measurement technique is just to basically just stick a little, it's like a ruler sort of thing into it. I don't know what it's called actually, even though I've used it a bunch of times, but it'll tell you your exact thickness, and you can do it immediately in lots of different places in the foam. So that'll work whether it's not cured all the way or completely cured. So yeah, that's pretty easy.
This tool, it's designed, it looks kind of like a pen with a skirt around it. And so you would stick the pen, it's got a very small diameter, about 1/8 of an inch in diameter. You push that against the foam and then you put the skirt up against it, and then you will be able to see the remaining amount of thickness that went into the foam and measure from there.
Thanks for being a lot more descriptive than me, Cassie.
So the next question is, what is the maximum thickness of the JM HFO?
So the maximum single pass thickness for the HFO is, I believe, 3.5 inches. We don't have the exact same recommendation for multiple passes, but you'll be able to find that on the technical data sheet on jam.com.
Just so you know, our helpful audience has informed us that the measuring tool is actually called a depth gauge, if you're curious. So just to make sure that we're all clear on that. The next question we have is regarding your TC data. Was the data presented for HFO blown product or an HFC blown product?
I'm not entirely sure what you mean by that. Can you repeat the question?
Sure. It says regarding our TC data, I suspect that they're referring to the data presented today. Was it presented for an HFO blown product or an HFC blown product?
This is just for the HFC product, Corbond III.
All right, thank you. The next question we have is for you, Chanel, and that is, how do you determine the speed of a pass for different thicknesses?
So that's dependent on a number of factors. We kind of refer to that as reactivity, how long it takes to get to the different stages of a spray foam cure. So that itself depends on your ambient temperature, your substrate temperature, and then also your processing parameters, your preheating temperature on the proportioner, the hose temperature, and basically what you're getting as the liquid material comes out of the gun. So it takes a little bit of experience for an installer to know exactly how long they need to, or I guess how fast or slow of a motion they need to make to get an exact thickness. That's something that you really get through practice, but again, you can use the depth gauge to check that.
Additionally, we go through different spraying techniques in order to meet desired thicknesses in our free spray foam installers training.
All right, thank you. So we did have one person write in when you guys were discussing weather, and his question was, if you apply it in the summer, it could ultimately turn out that in the winter, the spray foam cracks off. Is that correct?
That's possible. Winter versus summer formulation has to do with the reactivity during installation. It does not necessarily consider how the foam will perform in the long term. That has more to do with the spray foam formulation itself and whether it has better cold weather stability. So winter versus summer formulation, both of those, if a formula performs well in cold temperatures after spray cure, that's based on the formula, and both the summer and winter formula would have that property.
It can also be influenced by the installation technique. So if the spray foam was installed in the winter or in the summer and it cracks off in the winter, it is likely that an investigation would be needed to understand why that happened. That is not a common occurrence for us to see, especially when the foam was installed properly.
All right, thank you guys. That's very helpful. So the next question we have is, do you consider drywall to be a thermal barrier? And Cassie, I'm not sure why this would apply to spray foam, but maybe you could chime in here.
I believe that in some applications, drywall can be considered a thermal barrier between the attic and the living space. Chanel, can you comment on that?
Yep. Half-inch drywall is actually the most commonly used thermal barrier between spray foam and an occupied space. So definitely yes to that question.
All right, thank you. The next one is that, Cassie, I'm going to give this one to you, and that is we recently learned about something called a flash bat, which is a combination of spray foam and unfaced bat insulation. What are your thoughts on that in lieu of using a thicker system like what was discussed today?
I would say that John's Manville is an excellent resource for helping you design a hybrid system. This is something that we have done in the past in order to achieve high R values. I don't really think that the term flash is correct because that can be used as a 1/4 inch of spray foam or less. I think that as long as you get your closed cell spray foam in order to be the vapor or air barrier and which is required, you can absolutely put an unfaced bat in between. A system that we have done in the past and is 2 inches of closed cell spray foam in order to get your air and vapor barrier with a compressed R11 bat, and that will get you to an R20 in a 2x4 space. So that is absolutely something that we can help you achieve. Johns Manville offers a variety of insulation products, including spray foam and fiberglass mineral wool, blowing wool, and more. So we are the right insulation partner to work with you on hybrid systems such as a flash and bat, even though flash means 2 inches.
So I would actually just say that to be a vapor barrier, Corbond III, as well as actually most closed cell spray foams, requires 1.5 inches to be a vapor barrier. So flash could be as thin as that, but no thinner than the manufacturer's lift thickness required to be that vapor barrier, which will be on both the TDS and then the ESR.
All right, thank you. Chanel, the next question is for you, and that is, if you have a failed If you have a failed inspection and have to remove the closed cell, what's the best way to do that?
So that would be really a question to direct towards the tech team. We don't have them on this webinar, but those resources you explained, Kim.
All right, thank you. So again, you can contact that right now. And then I guess the next question, which makes sense, is Tech Connect a 24/7, 365 offering?
I believe it is. I will confirm on that, but at that number, you'll be able to leave a voicemail. I actually just got a note from one of my marketing. The Tech Connect is a 24-hour, 365 line. We are online, on call, and on site, available to answer all of your questions. Additionally, we've made some accommodations for COVID, and we're able to take more virtual FaceTime calls with our tech team. If you have something that you'd like to send pictures back and forth, our tech team is very good at responding, whether they're on your site or not.
All right, excellent. So we do have a couple more questions about the water-blown closed cell insulation, and Chanel, I don't know if we can answer this as this is not one of our products, but I'm going to go ahead and pose it, and I'll let you decide from there. So if the water-blown closed cell foam presents poor dimensional stability, what is the major factor for its lacking dimensional stability?
So this really gets into the chemistry of spray foam, which I don't really have time to get into today. But that's really a question of the actual formulation and making sure that the cell walls are strong enough to hold in the air as the blowing agent, essentially. But again, that's not something that JM offers. So, you know, it's not something that we can have really specific answers for.
All right, thank you. Kathy, I'll send this next one to you, and that is, can spray foam be used over bat insulation in a ceiling cavity? And if so, what other considerations must be taken into account?
So we have to go back to one of my first sentences that applied to all spray foam products, and that you need to install spray foam to a clean, dry, and sound substrate. Fiberglass will warp under the installation of spray foam through that exothermic reaction, so it does not meet the qualification of being a sound substrate.
Sorry, the question was not actually can it be installed on top of it, but could you use it in place of the fiberglass bat in a ceiling cavity?
Yes, you absolutely could use it in a ceiling cavity. Make sure that you work with your local building codes to ensure what needs to be taken into consideration, as you could be turning your home into an unvented attic, which just might have a few considerations to your HVAC system and others. Oftentimes in an unvented attic situation, if you are lowering the air changes per hour into your home, it's possible that you can reduce the size of your HVAC system. So just make sure that you're looking at the whole building science of your home before installing spray foam into your ceiling cavity, but it can replace bat insulation in a ceiling cavity.
All right. The next one is, I'm going to go ahead and give this one to you, Chanel, and that is, why does closed cell foam need 1.5 inches for a vapor barrier, but sheetrock only needs 0.5 inch?
So I apologize if I was a little bit confusing on this earlier. So closed cell foam needs to be 1.5 inch for vapor barrier. Sheetrock is not actually a vapor barrier. It is a thermal barrier. So really two different things.
All right, perfect. Well, that sums up our questions for today. We actually just had one more come through, and that is, can closed cell spray foam be used as a fire stop? Chanel?
No, not in itself. Closed cell foam actually has to be protected by a thermal or ignition barrier. It's a combustible material itself, so it would not be appropriate to be used as a fire stop.
All right, thank you. So there are a couple questions that were asked that we didn't get to today because they weren't quite on topic. So if your question was asked and not answered, we'll make sure that we send you a personal email following up with you to make sure your questions are answered directly. With that, just another reminder that the webinar will be posted online for you to review, and we'll send you an email when that's done, as well as the certificate of completion that's going to be in your inbox by Monday next week. With that, Cassie and Chanel, thank you very much for your time today. We sincerely appreciate it. Everyone else who's joined us, if you have any additional questions or would like someone to reach out to you to talk to you about them, you can notify us in the survey and we will follow up with you directly. Otherwise, have a great rest of your week. Everybody stay safe and start enjoying the fall weather.